Hi everyone. This week we're going to start Unit 7, which is about rational expressions and functions. Today we're going to do 7.1a. This section is split up over two different lessons. 7.1a is going to go over multiplying rational expressions and functions, and 7.1b is going to go over dividing. So our goals for today are to define what a rational expression is, because this is kind of our first time using them this year. Define rational functions and describe their domains, and then write rational expressions in the lowest terms, and also multiply them. Let's just define what a rational expression is. Rational expression is something that's basically a fraction, and with fractions we can't have the denominator be 0. So on top we're going to have a polynomial, on bottom we're going to have a polynomial, and then again the bottom polynomial cannot equal 0 since we're not allowed to divide by 0. And if it's a function, then it's just defined as a function, and again this function cannot equal 0 as well on the bottom. So let's talk about domain. When we're looking at domain of a rational function, we just have to remember that the denominator cannot be 0. So for this function, we have 3 over 7x minus 14. And again, we know that the denominator cannot be equal to 0. So what we can do is we can just set the bottom equal to 0 and figure out what value of x makes the denominator equal to 0. So if we solve this, we get 7x is equal to 14. So the value of 2 is what makes the denominator 0. So we know that our domain, we can kind of write it with these fancy little brackets. It's all values of x except for x cannot equal 2. That's the only restriction that we have on our domain. And then we'll end with those fancy brackets again. All right, for the next one, we have 3 plus x, and then on the bottom we have x squared minus 4x plus 3. So first let's factor the bottom, because that's going to make it easier to figure out what x cannot be. So this factors to be x minus 3, x minus 1. Because remember, negative 3 times negative 1 gives us positive 3, and then negative 3 plus negative 1 gives us negative 4. So, I didn't need that equal sign there. So if we look at the denominator, we just know the denominator cannot be equal to 0. So let's figure out what values of x make that denominator 0. We have x minus 3 times x minus 1. If we set that equal to 0, remember we solve with the zero product property. So x minus 3 could be equal to 0, or x minus 1 could be equal to 0. And we get a value of 3 and 1. Those are the two values of x that make this denominator 0. So we say our domain, again, we'll use these fancy little brackets. All values of x except x cannot be equal to 1, and it cannot be equal to 3. So that is the domain of that rational function. Okay, for our next example, we're going to write each rational expression in its lowest terms. So we're just going to be canceling things that are common on both the top and the bottom of our fraction. So for this first one, we have x plus 5 times x plus 2 up top, and on bottom, x plus 2 times x minus 3. So since there's an x plus 2 on top and bottom, we can cancel those, and we are left with x plus 5 over x minus 3. And that rational expression is in lowest terms. There's nothing more in common on top and bottom that we can cancel. Okay, for the next one, we have a squared minus a minus 6 over a squared plus 5a plus 6. So this is another one where we're going to need to factor it in order to be able to see what we can cancel and what we leave. So this one factors to be a minus 3 times a plus 2, and on bottom that factors to be a plus 3, a plus 2. So you can see the common factor on top and bottom is a plus 2, so we can go ahead, cancel those out, and we're left with a minus 3 on top and a plus 3 on bottom. We can't cancel anything because they do not have anything in common. All right, and the last one, we have y squared minus 4 over 2y plus 4. So the top is a difference of 2 squares. So remember that factors to be y plus 2, y minus 2. That was one of the special factoring patterns that we learned last unit. And then on bottom, we just have a common factor of 2, so we can factor out that greatest common factor. And you can see the common thing on both top and bottom is this y plus 2. So we can cancel that out. On top, we're left with y minus 2. On bottom, we're left with just 2. All right, so something kind of cool happens when you have the quotient of opposites. So if the numerator and the denominator of a rational expression are opposites, then the expression will simplify to equal -1. So I'm going to show you an example of how that works. So see here, we have opposite on top and bottom. On top we have m minus 3, on bottom we have 3 minus m. So see how they're kind of the same expression, just everything has the opposite sign. On top m is positive, on bottom it's negative, and vice versa with the 3's. So we'll show you why this cancels to be -1. I'm going to leave the top how it is, but on bottom I'm going to factor out a -1, which makes the 3 negative and the m positive. So you can see that when I factor out the -1, I'm changing it to be m minus 3. And then we have this common factor on top and bottom we can cancel. We're left with 1 over -1, which is just equal to -1. Okay, for this one, again, we have a difference of 2 squares up top. So that will factor to be r plus 4, r minus 4. Again, that's that special factoring pattern we learned about last unit. And on bottom, we have 4 minus r. So again, let's do that same trick we did last time where we factored out that -1. So I'm leaving the top the same. And then on the bottom, I'm going to factor out a -1, which is going to make the 4 negative and the r positive. So you can see this is the same expression as this one here. It's the same as r minus 4. So we can go ahead and cancel it. We're left with r plus 4 on top, a -1 on bottom, which really just changes the sign of everything up top, -r minus 4. All right, for our last example, we're going to multiply rational expressions together. So for number 1, we have 5p minus 5 over p times 3p squared over 10p minus 10. The easiest way to multiply these things together is to first factor if you can and cancel anything that's common on top and bottom of your two fractions. So this first numerator, the 5p minus 5, those guys have a common factor of 5, so we can go ahead and factor that out. Just going to leave this denominator the same, nothing to do with that. Same with the second numerator. And then on bottom here, they have a factor of 10, so we can factor that out. So see how we have a p minus 1 on top and a p minus 1 on bottom? We can go ahead and cancel those out. And then here we have a p squared on top and a p on bottom, so we can use those rules of exponents we learned back in Unit 5, and this p cancels with one of these ones, so we're just left with 1p on top. So we have 5 times 3, which gives us 15, and then we have this p, and on bottom we have 10. And the last thing we can do is just kind of cancel 15 or simplify 15 over 10, which is the same if we divide them both by 5, we get 3/2. So that's the same as 3p over 2. All right, the second one, we're going to have to do some more complicated factoring. We have k squared plus 2k minus 15. So that first numerator factors to be p plus 5, p minus 3. Okay, on bottom we have k squared minus 4k plus 3. Oh, why did I put p's instead of k's? Who knows what I was thinking? Let's fix that really fast. I think it's because in the last problem we were using p's. We'll change it to be k. There we go. Okay, K squared minus 4k plus 3, that factors to be k minus 3, k minus 1. We're multiplying that by this guy. K squared minus k, those guys just have a common factor of k, so we'll factor that out. And when we factor out a k, we're left with k minus 1. Sorry, that's a parenthesis there, it got a little messed up. And then on bottom, k squared plus k minus 20, that is k plus 5 times k minus 4. So let's go ahead and factor some similar stuff. We have a k plus 5 on top, a k plus 5 on bottom. We have a k minus 3 on top, a k minus 3 on bottom, and we also have a k minus 1 and a k minus 1. So what we're left with is a k on top and a k minus 4 on bottom. The last one, we have p minus 4, which is just over 1, times 3 over 5p minus 20. So we're going to leave the p minus 4, nothing to factor with that. Going to leave the 3. And then on bottom, 5p minus 20, those guys have a common factor of 5, and we're left with p minus 4. So we have p minus 4 on top, p minus 4 on bottom, and we're just left with 3/5. So that was the last example. If you guys have any questions, you're welcome to email me, or you guys can stop in for virtual office hours, and then next week we will continue Unit 7. Have a good day.